Alright, we have a story here of a rectangular backyard for a garden. And we have an expression with x in it in terms of modeling the size of it. And it says write an expression in terms of the perimeter. So that's the first word I need to understand. So perimeter is when you add all the sides. So we're going to add x plus 2x plus x plus 2x. We're going to add all the sides. And if I add that up, that's 1 plus 2, 1 plus 2. Add it all up, 6x. 6x represents the perimeter of it. And does it say if it's in? It's by the foot, and it's in feet. So we could also say that this is in feet. In the second part, it says the style of fencing Charlie wants costs $5 per foot. Use an expression to write for the expression to represent the total cost then, or how much it would cost to fence everything, which is the perimeter. So then the cost is, the perimeter is 6x, and we multiply that times $5 for whatever the perimeter is, and that together would give me 30x, and that would be in dollars. So if I know what x is, I multiply it times 30, and that would give me the cost. And then it says, if Charlie decides to use 15 feet for the length of x, what would the cost be? So we already have an expression 30x, so we put in 15, and then we multiply it out. So 15 times 3 is 45, and the cost would be $450. Did you try that on your own? Because it wasn't too bad, right? It'd be good if you tried it on your own. There's the right answer. All right, next one is this shape. It says there's a new playground that's being built at school. The rubberized ground under the playground will have this design. And the planning committee is considering a few different sizes for the playground. The committee would like to calculate the area of it for A, B, C, and D. The area of the rectangle is the product of the length, or length times width. So if I asked you for the area of this in terms of A, B, C, and D, I hope you see a rectangle here on the left, and the area of this rectangle is length times width, or A times C. We'll just call that AC. And then there's a second rectangle that's this long rectangle here. And so the length of it is D plus C. So I'm going to go D plus C, multiplying it times the width. So it's the length times the width, which is B. So this describes the entire area of this. Then I'm going to use this to figure out the area using different numbers for A, B, C, and D. So for the first one, it says the area is A is 20, C is 15, D is 10 plus C, which is 15, and you multiply that times B, which is 10. So let's see if I can do this without a calculator. That's 300. This is 25 times 10, and then altogether I get, and I like units if we have them, 550. Does it tell me what the units are in? Doesn't tell me any unit. Oh, does it? Oh, it does say. It says feet. So it's 550 feet squared. And now we're just going to follow that all the way down. Let's see if all the numbers are easy to work with, like that one. So here, again, we're going to use this up here and follow that. So A times C, that's 30 times 25. And then D plus C, that's 20 plus 25 times B, which is 15. So let's see if I can do this. So 30 times 25, that's 750. This is 45 times 15. I'm gonna, you don't even see it, but I got a calculator beside me. 45 times 15, that is 675. And then if I add that together, you could put them underneath each other, but it's 1,425 feet squared. All right, one more time. So to find this area, A again is 40 times C, which is 30, plus D plus C times B, and then calculate it. So 4 times 3, that's 1,200. Here, that's 65. If I double with a 0, right? No, it's just 65. So 65 times 2, so 130 to 0. Did I do that right? I want to make sure I did make it. Yeah, I think that's good. So if I put that together, that is 2,500 feet squared. I think we're doing okay. You never know, right, when I make a mistake, but I think it's okay. All right, turn the page. And it says, this is a graph of medicine taken and what the medication in a bloodstream. And there's questions based on this graph that we need to answer below. This always goes back to those that work in medicine, medical, hospital, nurses, doctors. They need to be good math people. They can solve problems and they're good with numbers so that we all are healthy and don't die. So, when is the concentration increasing or decreasing? So, good math here. It's increasing from the very beginning to what time? So if I go all the way here to 20. So for the first 20 hours, right? It's hours? Yeah. First 20 hours, the concentration is increasing. And then when is it decreasing is the next, I'm going to say next 21 hours. And this is the concentration. So the next 20 hours, the concentration is decreasing. Let's use that word. Concentration. So the concentration of medicine is increasing over the first 20 hours, and then the next 21 hours, it is decreasing. After how many hours is the concentration of medication at its highest? So that we said that. So it's at its highest at 20 hours. And we can call that a maximum. And then it says, what is the concentration at this time? So at 20, the concentration is 22, and then read what this says, parts per million. We're going to go 22 parts per million. Then the next is, what is the x-intercept, and what does it represent? So we have an x-intercept here, and it's 41 hours. And it says at 41 hours, the concentration is at 0. So that means no more medication in the bloodstream after 41 hours. So at 41, the concentration 0, which means at 41, there are no more meds in the bloodstream at that point. And what's the y-intercept? So at, or initially, let's say initially, there was 2 parts per million. Of concentration of medicine. So that's what that means. That's the initial amount. So initially there was 2 parts per million of concentration of medicine. So the y-intercept is at 0.2 and the x-intercept's at 41.0 if we wrote it as a point. There you go. All right, next one. This one or this one? So I did 101, 102. One more, 106. Okay. So it says Gregory is the proud new owner of a sailboat. And there are two sails, a head sail and a main sail in the back. The main sail is in the shape of a right triangle. So I'm just going to draw that. So here's my sail as a right triangle. And it says that one of the legs, that's the smaller side, is 31 feet shorter than the other leg. And the longest side is 41. And this is, what is the length of the shortest leg in terms of x? So one thing we need to remember, and you've done this before, is the Pythagorean theorem connects all the sides of a right triangle together. So that's, you take one leg and you square it plus the other leg and you square it, and it's equal to the largest side, the hypotenuse squared. All right, we're going to simplify this. And it says, what is the length of the short leg in terms of x? So the short leg actually is, this actually is going to go down here. So just the short leg is x minus 31. So the length of the short leg is just x minus 31. And then this work is going to go down here. So we're okay. So what's a quadratic equation that relates them all? We did that. And then what are the factors of this? So we're going to multiply this out. So one thing we need to do is that middle part, x subtract 31, we need to square it. We need to multiply it out. So that is x squared minus 31x. And then 31 times 31, so 31 times 31 is 961. So we have x squared. We now have x squared minus 62x, because I added those, plus 961, and then 41 squared. I have a calculator here beside me. So 41 squared is 1681.
Alexia Ortiz, please report.
We're going to combine like terms.
Alexia
So I have
Ortiz,
2x
please
squared
report to the main office.
minus 62x, and then I'm going to make this equal to 0 to be able to solve it. So to do that, I'm going to subtract 1681 to both sides. So 961 take away 1681, and that's a negative value of negative 720. So the next thing I notice is I can simplify this because 2 goes into everything evenly. So I'm going to divide everything by 2. And then we're going to go and carry this down here. So we have x squared minus 31x subtract 360 equals 0. Now, we do have a trinomial, and I'm looking for what are these two numbers. What are two numbers that multiply to 360 and add to negative 31? So I'm going to tell you something about Desmos that can help us factoring, because that's a big number, right? So if this is factorable, and I'm going to bring it across here, then I can type this in. So I'm going to type in x squared subtract 31x subtract 360. And what I'm looking for, you can zoom out and see the graph, but the most important part of the graph are the intercepts in the middle. So I'm going to zoom in here. So when I type that in, what are my x-intercepts? Those are my zeros, right? And I want you to notice the zeros are negative 9 and 40. So let me move this over. So negative 9 and 40. Those are my zeros. And how do zeros and factors relate? They are opposite numbers. So that means here, it's positive 9 and negative 40. They multiply and they add correctly. So what are the factors? And the answer is x plus 9 and x minus 40. Now, when I solve this, there's only one answer that makes sense. So my zeros are my answers. So if I solve each one, the zeros are my answers, but I'm going to cross out -9 because your sale can't have a length of -9. So there's only one positive value that X value can be for the sale, and that's 40. So I'm going to come back. I'm going to draw this triangle again. So I'm going to take this triangle and I'm going to plug in 40. So I have this triangle. I'll redraw it here. 41x, x minus 3, 31. So now that I know what x equals, so I know x is 40. I know the long side's 41. And then what's 40 take away 31 is 9. So now I have all the lengths. Now it says, what's the area of this sale? So I need to know the area of a triangle is half the base times the height. So for a right triangle, the base and the height make an angle of 90. So the hypotenuse is not part of the area. So base and height. So we have 9 and 4. So the area is going to be half 9 times 40. So 9 times 40 is 360, half of that, or half of 40 is 20. However you're going to see it. If I multiply this out, the area of the sale, and this is in feet, is 180 feet squared. All right, was that the last one, or did I give it one? I think that was the last one, right? All right. Let me double check to make sure that was the last one I gave you. But I think it was the last one. $106. Perfect. Hey, Mr. G Math over and out. I hope that helps. Thank you for trying it first and thinking through these stories. Till next time.